Taylor Creek, which Wesselman Creek flows into, and flows into the Great Miami right above the 74 bridge. You can see that the developed open space, low development, land use in suburbs, impervious surface is 40%. Conductivity gets a little high down here. The E. coli is moderately high too. That's over the standard 1030. There's a few optical whiteners. Whoa, what did it do? 2.35. Morgan Creek is of good water quality. Well, it isn't, 2.85. It's got problems with conductivity, ranking almost 5. It's got some problems with E. coli, 505. But it's still in the good category. Sand Run, land use, forest, and Sand Run flows into the Whitewater, and it's, as you'd expect, good. It's almost excellent. 2.08. It could make it very good water quality. We want to commend it, and of course it's primarily because the land use is still Fox Run. Deciduous forest, look at that. Fox Run is the second most forested watershed in the Great Miami River. Conductivity is low, pH is low, E. coli is low, chlorophyll is low. It looks like it ought to be good. Whoa, that's the wrong color! 1.9, that's supposed to be blue! Who made that slide? Anyway, we've got another excellent watershed, having said that, and that's because of land use. So land use is a pretty good indicator of what's going on. The mouth of the Whitewater River crops dominate 48%, but it's well forested. It comes out, it's got one that's 2, but I'm saying it's excellent. Whitewater continues to be our leader. They're doing a complete survey of the Whitewater status report right now. It's, the rough draft is already out on it, but we're delighted. Look at the conductivities, right where Brian said they ought to be, in that almost 500 range. Whitewater does have a little sewage going into it, but not much. The E. coli, almost non-existent. Chlorophyll, almost non-existent. Okay, Howard's Creek, that's what we're sitting on right here. Brian's going to talk about these, but look at the 700s, it's a little high. E. coli aren't bad, chlorophyll's not bad. But you can see that it's pasture and cropland. Dry Fork Creek, which receives Howard's Creek, is row crop, pasture, deciduous forest, and equal production, and it is 1.99. It makes excellent as well, and so this flows into the Whitewater. So we're delighted. Pasture and forest and crops are 90%. But we get to the Ohio River. The Ohio River is the cleanest water we've got. The conductivity is low. The pH is low. The phosphorus is low, is moderately low. Nitrate is a little high, but it comes up with excellent upstream. And this is the confluence where the Great Miami meets it. We reduce it a little bit. Lisa goes out in her kayak to get these some days. And the Oxbow these are eutrophic waters, but this year they all meet the good water quality component. All of them have a chlorophyll problem. 46, 50, 22. These are amongst the highest numbers that we're going to see, and I'll show it to you in a minute. The best tributaries, Stemple Creek, which I didn't mention, and 181, the Great Miami Whitewater Forest outflow and inflows are good. Dry Fork Creek and Pond 2 outhouse. This is a pond, not a lake, but it's these were the excellents, and then here are the very goods. This category. But you'll notice that you see Dry Fork Creek, tribs to Dry Fork Creek, Indian Creek, Lee Creek, small creeks, Whitewater River, Howard's Creek, all west side creeks, almost all west side creeks. And then we go to the worst ones, And these, the worst ones, we only had 2 that made yellow. That was Morgan Creek, which is a west side, is an east side creek that appears to get a lot of sewage, and a tributary to Taylor Creek near Snyder Road are really bad. But you'll notice that these are Wesselman Creek, these are all east side creeks. Taylor Creek, Taylor Creek, Taylor Creek. So those east side creeks that come off the urban use watersheds are in worse condition than the west side creeks that come off agricultural and forested watersheds. No big news. We look at the water quality rank of our tributaries. The median is 50%, the 50 is 2.1. And you can see they go all the way from 1.6 to 3.2, what we just saw there. So this tells us that the middlemost is good. We've got a fair number of blues this year, which we didn't have last year. What I've done here is just put the color code on the streams, the same one. You can see the blue ones over here on Howard's Creek, and you can see Fox Run, and the Whitewater, if I had one, I don't have it on there, would be blue, and almost all the rest of these are green. Well, I'm going to take a look at the main stem now. We'll start with the hydraulic year. The biggest thing, the difference between years is hydrology usually. Here's the rainfall at the Cincinnati Airport, 40 inches. That is right on the button as kind of our average. It was an average year. And this is the rainfall in the 5 days before a sampling event. And you can see that this March, April, May event had a lot of rain. Here's June event was the highest discharge. And the biggest rain of the year was right after that, but we didn't sample on that date. Here's the rain and discharge on our sample dates, discharge down here. You notice these 5 dates are very low, and the first 4 dates are fairly high, the highest discharge being in June, the highest rainfall being in May. Here's the discharge, again, seen over the January to December, and here are our sampling dates. This is on a log scale, so these are almost 10 times higher than those. So we had 4 high flow dates and 5 low flow dates for the median discharge, not on this slide, but it shows up somewhere. What happens to these parameters? Conductivity is a measure of the total salts in the river, and here's river mile from the Ohio River going upstream to the other side of US 27. And you'll notice that the conductivity is high coming in upstream in the Great Miami River, and it's also high in the tribs. So this is the river mile where the tributary enters the Great Miami River. So here's 6 miles is big because that's where Dry Fork Creek comes in, and 14 miles is big because that's where Taylor Creek comes in, I think. So we've got a decline in conductivity as we go to the Ohio River. These are Ohio River sites, and these are Ohio River sites. And we also get a decay in conductivity in the tribs. Now, I'm not quite sure why. Brian showed there's a gradient, though, higher conductivities north and lower conductivities south in the drainage. And this could be the natural drainage profile, or the groundwater feeds from are more important in the upper river, and they come out of waters that are more saturated with carbonates. The pH is a measure, remember a pH of 8 is 8.1 is about normal for here. And you can see that if we go to the main stem, there's no change in pH along the river from the Ohio River up. Ohio River is way down here, it's low, but it's pretty constant across. The average in the tributaries, although it's not a significant line, looks like it goes up as we go down to towards the Ohio River. I've got no explanation for that except the tributaries get bigger as we go down and have more potential for slow flowing water that pools that could support higher algal growth. Here's total phosphorus and nitrogen in the Great Miami River main stem from the Ohio River going upriver. And you'll notice that the the average nitrate is almost 4 milligrams per liter. 1 is our target, 5 is well too high, 4 is pushing it. And here's the average TP, 0.283. 0.3 is the upper limit for an urban stream. This isn't an urban stream. The target, high target for big rivers in the state of Ohio is 0.41. So as rivers get bigger, they get more phosphorus and more nitrogen because they become light limited and the nutrients aren't used as effectively. But you can see that they tend to go up as you go upriver. And this suggests that our nutrients are coming in from upriver. What's upriver? Well, a lot of sewage plants, Dayton, Hamilton, Middletown, you name it, and a lot of agriculture. So we're getting charged, we're the recovery zone here for the river before it goes into the Ohio, being used more intensively upriver than down. Here's nitrate with that 0.348. The median was 2 milligrams per liter. Not much change, but a general pattern. This is all of these are our sample dates, and that's the average of our sample dates. So this is the average. But here's the tributary streams, and the tribs actually are enriched as you come downriver. So that nitrogen that we see in the river, upriver, is sourced from the river, not from the tribs. Also, you'll notice that the upper value for the average is 1.39, about half of what's in the main stem. So our tribs are diluting the river. They're better than the river. Nitrogen load, we can multiply the concentration times the discharge. And what I've done is I've taken I've corrected for the area difference from the discharge in Hamilton to calculate the discharge at every point along the river. So this is corrected for the area from mile 0 to mile 35. But the average load is 7,000 kilograms a day. Oh, this should be backwards. That must be the median, and that's the average. The average is always higher. But you can see that that's driven by one event. What event would that be? That would be June, our high flow event. It was 20,000 CFS. So you can see that most of that loading came from that one day. The low flow periods are down here. Dependence of total phosphorus on discharge. Here's discharge from our high to our low. Here's June date, and you can see that it tends to go up. What you get is a curve like this. At low flow, the point sources dominate. As the rainfall increases, the discharge increases, it dilutes it, and it falls exponentially. And then you start picking up the particulate phosphorus on the bottom and the sides as you erode sediment, and it goes back up. And this is the curve that Dave Baker's got for at Heidelberg for the Great Miami consistently, but you can see even in our data that we have the same parameter. The total phosphorus looks like it goes upriver in the main stem, and it goes down in the tributaries, just like nitrogen. And the concentration in the tribs, the average is 0.338, 0.507 for the main stem. Again, the tribs are in better shape than the main stem. The tribs are diluting the main stem.
Mike, can I ask you a question?
Yeah.
In that last slide, you showed 7,000 to 9,000 kilos of phosphorus and nitrogen,
yes,
on average, come out of the Great Miami every day.
They do. We are the first of the big agricultural rivers going into the Gulf of Mexico.
And then down south of us, or downstream, would be like the Wabash, the Illinois River,
Wabash,
Tippecanoe.
The north-flowing rivers out of Kentucky are not major contributors of nitrogen phosphorus because they're pastoral and forested. They do not have row crop agriculture. Row crop agriculture starts on the Scioto. That's our first big river in Ohio. It puts in a lot of nutrients, and then comes the Little Miami and the Great Miami on a per square mile basis are the big sources of nitrogen and phosphorus that start the enrichment.
And the Muskingum and the Scioto don't contribute nearly as
They
much.
don't contribute.
Yeah.
The Muskingum goes to the Muskingum Watershed District. It's protected by lakes. Lakes take out 65 to 85% of the phosphorus as it settles to the bottom of the lake. So they kind of clean themselves, even if they were agricultural.